Keep your hats on, adrenaline seekers. We're ready to plunge deeply into the thrilling realm of aviation engine development. Imagine a high-stakes performance in which engineers go to extremes, such as blowing off fan blades, simulating storms inside engines, and even launching birds into the mix. This isn't your average backstage pass. It's a wild voyage through the risky dance of technology, invention, and logistics that brings these sky-high marvels to life. Prepare for a quick, sweet, and adventurous journey behind the scenes of aviation's heart and soul. The CFM Rise project, a dynamic cooperation between Safran Aircraft Engines and GE Aerospace, promises to be a game-changer as it embarks on the frontier of aviation transformation. This undertaking, which was unveiled in June 2021, is more than just constructing an engine. It is also about creating an aviation masterpiece. The CFM Rise deviates from the tendency of simply increasing engine diameters by introducing a paradigm shift. Consider this: a 13-foot rotor diameter, open propellers, and a commitment to sustainability that cuts CO2 emissions and fuel consumption by 20%. Rather than following the typical script, the CFM Rise has a core that is not only compact, but also ingeniously efficient. Recuperators take center stage, capturing exhaust heat energy and repurposing it as a hint to a more sustainable aviation future. But wait, there's more. This isn't your normal counter-rotating assembly. Fixed second-stage blades and active pitch stators steal the show, providing varied control that previous turboprops could only dream about. The CFM Rise is built with manufacturing quality in mind. Carbon fiber composite blades are precisely produced through 3 sieve weaving techniques. The hot portion combines cutting-edge ceramic matrix composites with future metal alloys. It's more than simply an engine. It's a symphony of creativity. Consider the turbine and rotor dancing in perfect unison, linked by a reduction gear set. This isn't just engineering, it's moving poetry. And since we're on the subject of motion, the CFM Rise doesn't just promise sustainability. It delivers a hybrid electric powertrain that reduces fuel use by 20%. Securing design approval is the critical first step before engines come to life in the complex world of aviation engine design. Engineers work behind the scenes to dedicate fleets to fulfill specific contractor specifications. While time-consuming and resource-intensive, this stage is critical in the development of high-performance engines. The Rolls-Royce Trent XWB is a perfect example of this trip. The 6-year journey began in 2004 when Airbus sought a replacement for their A350. Rolls-Royce won the contract in 2006, and the first A350 powered by Trent XWB engines took to the skies in 2010. A spectacular symphony is unfolding at the jet engine assembly plant in Derby, UK, with a new engine being built every 20 days at an astounding cost of $35 million. What may appear to outsiders like rocket science is just another day for talented individuals managing accuracy and innovation at the heart of aviation technology. The delicate choreography of aviation engine assembly begins with the creation of a fan disc, a tough marvel built to hold 22 razor-sharp blades. Sharpened to the chef's knife accuracy, each blade is perfectly positioned by professional specialists. Analyst fillers improve airflow efficiency, resulting in a work of art in the form of the XWB engine's main component, the massive fan. This seemingly regular procedure develops as a stunning ballet, raising aviation invention to the realm of engineering brilliance. In the back of Rolls-Royce's Derby headquarters, the engine's pulsing heart takes center stage. The turbine in the shaft, which drives the fan, becomes the focal point. The engine's back is marked by a low-pressure turbine hanging vertically with crane-like accuracy. Skilled craftsmen methodically assemble the core, revealing the engine's sophisticated inner workings one component at a time. The precise dance that begins the awe-inspiring journey of aviation engine assembly begins with the fan disc, a marvel intended to cradle 22 razor-sharp blades. Skilled specialists, analogous to choreographers, place the huge blades with precision, creating a symphony of airflow efficiency. The end result? The huge fan, The XWB engine's showpiece takes center stage with an intimidating diameter of 140 inches, ready to drive aircraft into the skies. Meanwhile, in Rolls-Royce's Derby headquarters, the engine's heartbeat, the turbine in the shaft, steals the show. Workers suspended vertically build the core with crane-like precision, revealing the inner workings. This is no ordinary assembly. It is a work of engineering genius. In a separate segment, the fan undergoes a mesmerizing transition as it moves to the next level. This isn't just a case of nuts and bolts. It's a precision symphony in which every wire and pipe is crucial. Skilled technicians use electronic models to verify every detail, assuring faultless assembly. A rotating arm smoothly spins the blades as the fully completed core meets the fan and the fan casing, harmonizing with a beautiful array of 68 turbine blades that spring to life, providing more power than a fleet of 300 automobiles. This is a symphony of precision, power, and aviation innovation, establishing the future one meticulously placed component at a time. The assembly of an aviation engine, a 20-day precise symphony, is only the beginning of its transforming journey. Before it takes to the skies, the engine is subjected to a stringent testing regimen in Rolls-Royce's high-tech control center, where an operator acts as a virtual pilot. In a rigorous dance, safety takes center stage, ensuring every lock is closed before the engine roars to life, encased in a technological cocoon where innovation and safety converge. The engine's heartbeat is painstakingly chronicled in a symphony of tests within this purpose-built fortress, each test a chapter in its evolving biography. Pass-off testing, a demanding evaluation exceeding all standards. Research testing, delving into undiscovered realms of creation. And development testing, the ultimate finale pushing the engine to its limits, extracting maximum power and efficiency, play out. This isn't just testing. It's a great spectacle in which every movement advances aviation toward the future with unparalleled accuracy and power. Rolls-Royce engineers toss caution to the wind in the risky realm of engine testing with the fan blade off test, a spectacle in which one blade purposely says farewell, stressing the system's ability to control the unexpected. But the excitement doesn't stop there. Prepare for the water ingestion test, which simulates a deluge to assess the engine's resilience in the face of a storm. The drama takes flight with bird trials, in which engineers introduce avian difficulties into the engine to test its durability in unexpected encounters. The cold start test follows, submitting the engine to an ice embrace overnight before witnessing its triumphant thaw, a tribute to its resilience in extreme weather circumstances. This testing theater is a story about resilience, durability, and flexibility, not just meeting standards. Each trial is a revelation, a test to build engines that can not only navigate but also conquer the skies in every condition. After successfully completing the testing process, the engine is ready for its big finale, delivery. Most engines travel on flatbed trucks, which are typical sights slithering through landscapes. However, the drama heightens for excellent performances. Consider Rolls-Royce engineers staging a spectacular performance as they load the engine onto a cargo ship heading for Hong Kong Airlines. A trailer awaits on the other side to guarantee that this technological marvel finds its way to its new home, bringing the remarkable ballet of aviation logistics to a close. The delivery path chosen by Rolls-Royce in the grand finale of this incredible voyage is far from ordinary. It's a monument to their constant dedication to a worldwide customer. When time is of the essence, the engine returns to the skies, cradled by the massive wings of a gigantic cargo plane like the classic Airbus Beluga. This isn't just about delivering an engine. It's the culmination of a journey that began with innovation, progressed through precision assembly, and now ends with the engine extending its wings to embrace the skies it was born to conquer. The beautifully made engine container appears as the trailer arrives at the waiting facility. The stage is prepared for the delicate process of mounting the engine, which will signal the end of its extraordinary trip. Consider the arrival of Airbus A350 engines to the Toulouse assembly plant, where the Rolls-Royce Airbus relationship takes center stage. Station 20, the penultimate assembly station, morphs into a theater, setting the stage for this precise symphony's grand conclusion. The Trent XWB engine, the star of the show, adopts a beautiful stance on a hydraulic crane within the plant. This 8-ton masterpiece, worth $32 million, is carefully moved to its mounting site. The rigger's assembly process follows, in which nearly all 20,000 parts are expertly assembled. Perfection is more than a goal, it is an unwavering obligation. Every skilled touch protects against any errors that may cost millions of dollars, emphasizing the critical importance of craftsmanship in this breathtaking aviation finale. The spectacular finale of the engine unfolds as it is securely fastened with an amazing 50,000 pounds of push on 2 sturdy brackets. The hydraulic transport vehicle makes its final appearance, signaling the end of grueling tests that ensured the Rolls-Royce engine's readiness. The airplane is now ready for duty, adorned with this fuel-efficient marvel, a perfect marriage of human invention and technical mastery. When it comes to the worldwide aviation engine market, the figures are mind-boggling. The market is expected to reach $87.38 billion in 2022, with North America accounting for $38.1 billion, and is expected to rise to $187.26 billion in a decade, boasting a phenomenal 7.92% annual growth. 4 main players have stakes in this financial landscape. With a modest 12% stake, Rolls-Royce sets the stage for industry heavyweights. General Electric Aviation comes in second with 14%, but Pratt & Whitney takes the lead with 35%, surpassing the combined share of GE and Rolls-Royce. CFM International, the unchallenged leader, commands a commanding 39% share, propelling the vast majority of the world's aircraft into the boundless sky. Pratt & Whitney's heritage shines brightly in aviation history, with 13,000 engines accounting for 26% of the market. Boeing, Lockheed Martin, Airbus, and Northrop Grumman have sway not only over planes, but also over orders, influencing the global engine industry. This sophisticated ballet of numbers frames the aircraft engine market as critical to the future of aviation. Air India ignites a propulsion revolution in the dynamic world of aviation by buying 40 GE NX engines, 20 GE 9X engines, and an ambitious 800 LEAP engines from General Electric Aviation. Rolls-Royce unveils the operational Rolls-Royce UltraFan, a technological marvel with a 140-inch diameter, 5% larger than the GE 9X, with thrust ranging from 25,000 to an astounding 110,000 pounds. As the Rolls-Royce UltraFan nears completion, the question of whether it will formally dethrone GE as the world's largest aircraft engine increases. While General Electric's GE NX delivers an amazing 134,300 pounds of force, Rolls-Royce's UltraFan poses a formidable competition. The stage is prepared, the engines are ready, and the question lingers: will the UltraFan rise to the throne, dethroning the reigning champion of aviation power? The outcome of this high-stakes battle appears to be determined in the skies. The aviation industry is on edge as it awaits the sky-high confrontation between Rolls-Royce's UltraFan and GE's reigning champion. Which engine will be crowned king? Keep an eye out for the spectacular climax to the saga of aviation power. Don't miss out on the newest information and interesting developments. Join the conversation by subscribing, liking, and commenting below. Let us soar into the future together, where creativity has no bounds and the sky is a canvas of limitless possibilities. Fly with us and see aviation brilliance evolve.